Hi there, Amanda Pilz here for Chemistry 125, here to do lab number 4. Today's date is September 9th, 2024, and for today's lab I am in my bathroom instead of the kitchen. There is a purpose for that. I want to be over a sink because today's lab might get a little bit messy. For today's lab, we are going to be doing the water balloon over the flame experiment to represent the basic principles of heat transfer and the specific heat capacity of water and air. Now let's begin today's experiment with a scientific analogy. We have two people walking up a large hill with their backpacks. Person A will represent water, is walking up the hill with a large heavyweight backpack, and this represents water's heat energy. As they walk up the hill, they can keep packing in more and more items without feeling too heavy or getting too weighted down. This represents water's high heat capacity. It can absorb a lot of heat without its temperature rising significantly. Now person B, who will represent air, has a small, lightweight backpack that can only hold a few items. As they add more items, or heat, they feel the weight almost immediately start to slow him down quickly. This represents air's low heat capacity, so even small amounts of heat can make air's temperature rise very significantly. This analogy illustrates how water can hold more heat energy than air for the same increase in temperature. This makes water much more efficient at absorbing and storing heat. So for today's experiment, let's talk a little bit about our materials. I have a couple of balloons. One I'm going to fill with air, and the other I'm going to fill with some water at the bottom and then a little air at the top. The other item I have is a lighter. That'll represent our heat. So let's begin by, off camera, I'll fill this balloon with air and this balloon with some water with a little air at the top. I'm not going to fill this all the way with water, but I'll have some water at the bottom. Okay, I've got my two balloons filled, one with air and one with a little bit of water and some air. But before we do our experiment, let's talk a little bit about specific heat capacity of water. Specific heat capacity is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Water's specific heat capacity is 4.184 joules per gram Celsius, which is much higher than most materials, including the rubber of the balloon. This means that the water can absorb a lot of the heat from the flame of our lighter before it gets hot enough to cause the balloon to burst. In contrast, the rubber of the balloon alone has a much lower heat capacity, and without the water inside to absorb the heat, it would quickly overheat, weaken, and burst. As the flame applies the heat to the balloon, water absorbs the heat and distributes it throughout the liquid. Since the water absorbs most of the heat, the temperature of the balloon's rubber does not increase enough to cause it to weaken and pop. Water also conducts heat differently, helping to spread the heat from the flame across the volume of the water, further preventing localized overheating of the balloon's rubber surface. So, first what we'll do, as a control, is we'll take our balloon with all the air and take a flame and we'll kind of run it underneath. And we'll see what happens. So that's a good representation of how low the heat capacity is for air. Now let's do a little demonstration on the balloon that has the water at the bottom. It may be kind of hard to see on camera here, but there is a little bit of water on the bottom. Alright, so I'll take my lighter and my balloon here, and I will heat it a little bit, and as you can see, the balloon is getting a little black there from the heat, but it's not popping because the water is absorbing that heat energy. It has a much higher heat capacity than air is. But if we're doing that under the water, but if we do it on the part that has the air, it pops, which is why I want it to be over a sink. So, to reiterate, the experiment we just did demonstrates the protective effect of water's high heat-specific capacity. The water inside the balloon absorbs the heat from the flame, preventing the rubber from overheating and bursting. Air, on the other hand, has a much lower heat-specific capacity, so the balloon bursts when exposed to the flame. And I hope you enjoyed this positively fabulous example of heat capacity.